day all of you. Today's gate question is, in a given sequential circuit, initial states are Q1 equal to 1 and Q2 equal to 0. For a clock frequency of 1 MHz, the frequency of signal Q2 in kHz is. Okay. So this is the circuit given. You have to find the clock frequency of Q2. Here Q2 is the output. You have to find the clock frequency of Q2. What is actually the clock frequency of the circuit? The clock is 1 MHz. Okay. So to find the clock frequency, now how to do this? Just you go for functional table. Follow it carefully. You draw a table. This table consists of first clock, then the inputs D1, D2 and the outputs Q1, Q2. Okay. So when there is no clock, you have to start the table like this. When there is no clock means initial state. This is called initial state. At initial state, yes, in the problem they are given Q1 is equal to 1 and Q2 equal to 0. So just write Q1 equal to 1 and Q2 equal to 0. Okay. And what is D1 from the circuit? Yes, D1 is, yes, you can write it as Q2. And what is D2? Yes, it is Q1 bar. This is the initial state. Okay. So now when you apply first time the clock, yes, what happens? D1 is Q2. So Q2 is 0. And D2 is Q1 bar. Previously it is 1. So it becomes 1 bar. So it is 0. So what about D flip-flops? D flip-flops, the work of D flip-flop is it will send the input as it is to the output after some delay. That's all. It won't change the input. Okay. So that is the reason. Yes, D1 input and D2 input both are just go like this. D1 input is 0. So Q1 is 0. D2 input is 0. So its output is also 0. Okay. Then whenever the second clock pulse is applied, again what is D1? It is Q2. Q2 here is, the previous state is 0. Q1 bar is, yes, the previous is 0. So it is Q1 bar. So it becomes 1. As it is, gets shifted as outputs. These two logic inputs get shifted as output. Then clock pulse 3 is applied. Again Q2 is 1. Q1 bar, 0 bar is 1. So as it is, you'll get 1, 1. Next, whenever the clock pulse 4 is applied, then yes, it is 1. Q2, 1. Q1 bar, 0. So as it is, you'll get this. Okay. Now if you observe the outputs at clock 4, these two are equal to the initial states. Means again the circuit work will repeat. Okay, if suppose this repetition is not happened at 4, you have to go for again the clock 5. Okay, so you have to stop at which again you'll get the first condition. Okay, so now if you observe after 4 states, the circuit function is repeating. So therefore the total number of finite states is equal to 4. Therefore, the frequency of Q2 or output is equal to actual clock frequency divided by 4. What is the actual clock frequency? 1 MHz divided by 4. So what is this? 1 MHz divided by 4 is 250 kHz. Okay. So the answer is 250 kilohertz. Okay, simply you have to write a functional table. Functional table. Okay, in that table, first row is, the first thing is about the initial state, and then as D1 equal to Q2 and D2 is equal to Q1 bar, just by applying successive clock pulses, you have to observe what is D1, D2, Q1, Q2. You have to stop applying the clock whenever, yes, the state Q1, Q2 is repeating. Okay, so now count those states, and those are called finite states. Now the frequency of output is the actual clock frequency divided by those finite number of states. You're going to get 250 kilohertz.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.